Welcome to another spectacular and dazzling Math 130 lecture here with yours truly, your professor, Mimi Rasky. So today we're going to be looking at matrices using two-dimensional arrays and Java code. And matrices in mathematics are a wonderful way to demonstrate how powerful the 2D array is in Java. So let's take a look. We're going to define what a matrix is at first here. A matrix is simply a rectangular array of elements, typically real numbers. Let's start with some of the basic notation for matrices. Usually a matrix is denoted as an M by N matrix, and this is the size or dimension of the matrix, where M denotes the number of rows and N the number of columns. And the entry in the ith row and jth column is denoted A with a subscript ij. And so usually they name matrices with capital letters in mathematics, for example, A here. And this is just a generic M by N matrix shown here. Notice the first entry is A with a subscript of 1, 1 to say that that's in the first row, first column, and then the next one here next to it in the same row is A1, 2, the first row, second column. But remember, in Java, we start counting at 0, so this entry here for us is really going to be the 0th entry, because real programmers count from 0. So the brackets around the table of elements here can be used to denote your matrix, and sometimes, depending on the textbook, you may see them as large parentheses instead. But either way, it denotes a matrix. So let's take a look at our first example. We're going to talk about what a transpose of a matrix is. So the transpose of a matrix A, and they denote it with an A subscript capital T for transpose. It's a matrix that you can form by writing A's rows as its columns, or even vice versa. So what would A transpose look for this example? Well, you'll notice this first column here, I'm just going to write that as a row, 1, 4, 5, -4, and the second column I'll write as the second row here. And this matrix here is the transpose of A. And notice that the dimensions of A were 4 by 2, because there were 4 rows and 2 columns, but the transpose is always the reverse. So this transpose has dimensions 2 by 4. So how could we do this in Java? So we're going to write a method named transpose that's going to accept a 2D array and return its transpose. And the transpose is also an array, so that means the return type will also need to be a two-dimensional array. So if we start the header here, public, static, and we're going to return a two-dimensional array. So, and we're going to go with ints, although technically they could be decimal values also, but I'm going to keep this fairly simple. And then I'm going to put a pair of brackets here to denote the return type is going to be another two-dimensional array. And we're naming our method transpose, and then we're going to give it the int 2D array, and we'll call it, and it's up to you what you want the local variable to be called. How about just array? So when we start our method, I'm going to immediately declare a new two-dimensional array, and I'll call it array transpose. And now remember, when you declare a matrix or a 2D array, you use the new because you're declaring a new object here. But then what's going to be the dimensions here? So in these brackets, the number of rows is going to be the number of columns that the array that is the parameter. So this size inside this bracket, I'm going to go array, bracket, bracket, and since these matrices always have the same number of columns that they do rows, I'll just use the 0th row's length will be the length of, or how many rows this new matrix will have, and then how many columns will be the same as the array's number of rows, which we use the length field, ra.length. So there's the creation of this new array, but it's not populated yet except for with zeros, which Java does that for you for free. So we're going to first declare a couple of ints. How about if we let M be the number of rows that the original array has, and N be the number of columns, and this way we will save the CPU from constantly checking how many rows and how many columns that we have. So when we do our nested for loops to traverse the arrays, so we're going to go for, and we'll start here with, how about int, if you like you can use I and J, I'll use row and column. Row equals 0, row less than array dot length, and then row plus plus, and then we begin the inner loop for parentheses int, I'll do call for short for column equals 0, semicolon, column less than array subscript 0 dot length, number of columns that the array has, and then column plus plus, and then inside this loop I'm just going to have a one-liner, and all it's going to be is you're going to populate array transpose, and this is the part that's a little bit tricky because remember these brackets here aren't going to be row and column, they're going to be reversed. So you're going to put column, row, and you're going to take the elements from the original array, the parameter here's row column, and put them in the column row element, because that's the whole definition of transpose. And then you're done with that, and then of course after you're done with these nested for loops you need to have a return statement, and so we're going to return the now populated array transpose, or a two-dimensional array. And what would this look like in main? How would you call this method? Since it returns a 2D array, you better make sure that it's going to capture the two-dimensional array. So we're going to go into NetBeans right now and check it out. So here I have in NetBeans already, I have public class array transpose, and I have my main, and I created some matrix here already for us. I called it A matrix, and I explicitly initialized it. You can see it's that same 4x2 matrix in your lecture notes. And then I did a half declaration for the A transpose. I called it just A capital T. And so int bracket, 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 AT, and then in the very next statement, I do my method call. So AT is going to be equal to whatever the transpose method returns, and the argument sending it is the A matrix. And then I'm going to print out here in main what that transpose looks like. So I just have the words, the transpose of the matrix is shown below, and I have a nested for loop to traverse that brand new A transpose and print it out. And you'll notice I'm printing it out on a nice, pretty row by row basis. I'm using I now and J. So the outer loop I equals 0, I less than the length of the transposed array. And then that is going to be my outer loop controlling which row I'm on. And the inner loop's controlling the column, J equals 0, J less than the transpose's ith row dot length. And in here I do my system.out.print, because I don't want to go to the next line after every single element. I'm going to print the ij element and then have spaces in between, and then this is outside of the inner loop, forces a new line. And we're done with main here, and then underneath we have the header for our transpose and then the body. And so I just basically put everything that we talked about handwritten. So if we actually run this code, let's see if it runs. I've already debugged it. It didn't run first time. So the transpose of the matrix is shown below. So there we have it shown kind of pretty. You notice that it's not exactly lined up here very nicely. So how would I fix that? Well, one way I could put maybe a few more spaces after each of them, but a better way to fix it would be to use a printf statement. So if I did that, I would do double quotes, and then I would do my format specifier %d, and maybe we want to do %4d. We'll make it a nice format specifier, and then we'll put double quote comma, and then we'll have the corresponding variable to that format specifier, and we don't need any concatenators. So if I do that, will it make it look prettier when it prints it out? Let's just find out. Oh, yeah. See how they're more in alignment? Okay. And that is the end of the array transpose example. Please go to the next video to see the sum of two matrices. Happy programming.